Hello and welcome to Chapter 2, Lesson 1 on Elements, Compounds, and Mixtures. Now, those first two things, elements and compounds, fall under the category of pure substances. A pure substance is any substance that has the same composition throughout. So starting with elements. Elements are the basic building blocks of matter. The forms of matter don't get any simpler than the elements. They are found on your periodic table. There are exactly 118 of them, 90 of which occur in nature. So an element, or another way to put that is an elemental substance, contains only atoms of one given element, although those atoms could be arranged in a couple of different ways. For example, elemental oxygen could be O2 or it could be O3. So some examples of elements: we have gold, we have mercury, we have red phosphorus. I could go on and I could list all 118 of them, but I won't. Moving on to compounds. Compounds are two or more different types of elements that are chemically bonded together, right? So here, this black ball is a carbon, these two red balls are oxygen, and you can see that there are chemical bonds that are connecting them. And in order to break these bonds, that would require a chemical reaction to take place. So, some examples of compounds: there are literally billions of examples of compounds, but some are table salt, NaCl, sugar, C6H12O6, carbon dioxide, shown here, CO2, water, which is H2O, and etc., and etc., and etc. I could not name all the compounds. Then we come to mixtures. So mixtures are not pure substances because mixtures have a varied composition throughout, and the different substances within a mixture are not all chemically bonded to one another. Now within mixtures, we have two different categories: heterogeneous mixtures and homogeneous mixtures. So, a heterogeneous mixture, as the prefix hetero suggests, is a mixture containing two or more different things that is not uniform throughout, right? So you can tell the difference. Hetero is for different, right? So different components of the mixture can be distinguished from one another, right? So a cheese or a pepperoni pizza here is a mixture of pepperonis, cheese, tomato sauce, bread, etc., right? And I can easily distinguish that over here we've got a little bit of a pepperoni dense region, whereas up here there are not as many pepperonis. I can distinguish the components of this mixture very easily. I can pick out and point out the individual pepperonis and where the cheese stops and ends, right? So some examples: a bowl of cereal with milk, right? I can point out there's the cereal and there's the milk. Sand, you have to look a little closer. You might even have to look under a microscope, but you can still, if you look closely enough at sand, you can see those individual grains, those individual rocks that look slightly different. So it's not uniform throughout, right? You can distinguish the different components. The other type of mixture is a homogeneous mixture. And once again, we have our prefix homo, meaning the same. So a homogeneous mixture is completely uniform throughout, even if you put it under a microscope. But although the components can't be distinguished from one another, they're still not chemically bonded together, which means it is still a mixture. So for example, an alloy such as bronze and brass, right? These are brass tacks. We're getting down to brass tacks now. And even though these brass tacks, you can't distinguish the copper and the zinc that make up these brass tacks. Even if you put them under a microscope, you wouldn't be able to see where the copper and the zinc are, delineated from one another. But the copper and the zinc are not bonded together. There are no chemical bonds between any atoms of copper and any atoms of zinc, and so brass is still a mixture, right? Salt water is another example. The atoms of sodium and chlorine are not bonded to the water molecules. So even though you can't tell the salt from the water when you look at just a glass of salt water where it's all dissolved, those are still two different substances that have been mixed together. And air, you can't distinguish the molecules of oxygen from the molecules of nitrogen, but when you're breathing in air, you're breathing in both oxygen and nitrogen, as well as a few other trace elements. So here is our flowchart. We start at matter, which is defined as anything that has both mass and volume, and then we can sort it into pure substances, which are elements and compounds, as well as mixtures, which can be homogeneous or heterogeneous. So you might want to take some notes on this flowchart, copy it down, or just take a picture. Otherwise, that is the end of Chapter 2, Lesson 1. I hope you enjoyed it, and I will see you next time. So long.